In order to wind these toroids, I've taken the core and placed it in this little plastic holder. Now these came 2 in a package. They have apertures here to hold different size cores. I believe these come in, as they say, paired, which gives you the ability to hold 4 different cores, 4 different size cores. They're very well made. They have indexing pins. I believe they came from QRP Me, which is the same place I purchased, if you've seen my videos before, these little fellows. I believe this is called a 2-inch machinist vise. It's made in China, of course. Wholesale tool company sells these. They're nice on a bench like this for holding things just like this. This is 1 turn right now. Every time the wire passes through the center of the toroid, that counts as a turn. So 1 turn, that's the 2nd turn. So we have 3 turns. I'll continue on until I get to 22. If you're sure you have enough wire, you could take the end of the wire and tuck it down between the plastic and the end of the vise, and that way you wouldn't have to hold on to it. Looks like I may be missing a capacitor. I can't fault the kit seller for that. I've probably been in and out of this package a number of times. Circuit board comes in a little sealed package. Now this board I have is not solder masked. However, the new ones that are advertised today are solder masked. I proceed to stick all these 3 whole components into the board. I've got some of the small parts installed already. In order to do this, you need to take the parts list or the bill of materials where there's designated C1, C2, 3, and work with this placement diagram. C1 tells you what size it is, and C1 goes here. C2 goes down here. With these 2 pieces of paper, you can pretty well put all these things in, see? There's C1 and C2. Parts are not called out on the circuit board, neither by call out number. L1 and L2 are called out. The 602 is called out. Of course, that'll get covered up once you put the socket in. So work it with the parts list and the parts placement drawing, and you'll be okay. A good way to hold this socket in place where you solder it is one of these reverse acting tweezers. These are machine pins and they don't bend very well. While we're discussing the socket, make sure you note the cutout here, and I don't know if I can get that clear enough to see. See the cutout here? So make sure that socket's installed as shown on the drawing. If you use a reasonably sized tip and rather small diameter solder, the lack of a solder mask is not a problem. Doesn't mean you shouldn't take a glass and examine the solder work to make sure you haven't inadvertently bridged over. Now these are not identical, so make sure you pick out which is right. So this is the transistor, and it's Q1. Which is here. Okay, so the flat side is oriented that way. Looks like the crystal socket plugs in here. Well, the crystal socket's mounted here. Now, the tweezers are in between two of these terminals, so I'll only be able to solder the one on this end. The electrolytic capacitor mounts here and here, and it's polarized, plus and minus. So the long lead goes in the plus. And the negative marked side of the capacitor goes in the negative. I'm missing C5. It goes in these two holes right here. And then the two toroids go in this hole, and then here and here, covering up L1 and L2. I'm going back to my coil winding chart. I decided I had this one with 22 turns to be applied to it. Well, I found this piece of paper inside the plastic bag, and it verifies that these are indeed 3761s, but down here it tells me 23 turns of magnet wire. I'm going to go ahead and wind 23 turns. That is, I'm going to add a turn to the 22 turns already on here. I can always take off turns. I'm not going to install this regulator right away. I don't know what I'm going to use for power supply yet. This is an 8-volt regulator. There's discussions of using a 5-volt regulator. I've seen this thing powered, I think, with 9 volts for a battery. I may use internal batteries in whatever I decide to enclose it in. The last thing to do is put the integrated circuit in. The legs are a little bit bent outward. What I usually do is just roll it until the legs get more or less at right angles to the body. It looks pretty good. Now remember, there's a notch in the chip as well as a notch on the socket. They all have to line up. Very important now is to make sure that these pins are all started in the holes. It's easy to wrap a pin underneath and not detect it. And because this is a high quality machine socket, it's not as forgiving for a little bit of misaligned legs. Last thing to do, and I haven't decided for sure whether you'd use the 4 megahertz crystal. So I'm not going to cut the legs off until I do a little bit of experimenting. Normally I'd shorten the legs up so it fits down flush against the socket. And since we do have a socketed crystal, I might take a short piece of bare wire and go from here to here to sort of make a brace to keep it from wiggling and falling out. I don't want to go from the top of the socket to here because this is my frequency adjustment for the crystal. Something needs to stabilize this crystal, even with shortened leads. I'll come back a little bit later with part. We'll see it in operation. Maybe here is in operation.